atmospheric composition and human respiratory circulation, in line with aviation. Well, before I proceed, I'd like to wish everyone their safety and, of course, their family's safety. I hope we all get through this, and I hope we spend our time during this quarantine period to do something useful and do something productive. Well, I am your presenter for today, Crassius Xavier Pascual, and I hope we all learn from today's presentation. And I wish you all a good day. Well, I'd like to, before we get started with, everything, I would like to discuss our atmospheric composition. Our atmosphere are divided into four categories, which are the troposphere, the stratosphere, the mesosphere, and the thermosphere. These are said in chronological order, from lowest to highest, and these parts of atmosphere have, of course, different temperature and pressure, and different composition and density. This just proves that flying an aircraft into our atmosphere takes a lot of consideration. We cannot just build an aircraft that flies without taking everything into consideration. A human body can only withstand certain temperatures, pressures, and conditions. Now let me show you a graph wherein a different pressure and temperature are shown in figures. So if you look at it, the troposphere is the lowest at 20,000 kilometers above sea level. You'll see the temperature drops at negative 40 degrees Celsius, and I can tell you it is very cold. It's above, I think, the Mount Everest. And then as it goes higher, it drops a little bit lower. Then, well, it actually plays around, going up and going low. And during stratosphere, we have our temperature at 0 degrees Celsius, and this is a stratosphere is actually the threshold of an airliner. Although some aircrafts have flown higher than 45,000 feet, but those are military grade, and those are for experimentations. But airliners, usual C-130s of the military are just flying at 45,000 feet. And as you can see, at 45,000 feet or 50,000 feet, you'll experience a very cold weather. And then we have, of course, the mesosphere and the thermosphere. And since we are not flying above, I think, mesosphere, we're not going to discuss that one. And then the second graph is the pressure. Well, you know what they say, the higher we go, the lower the pressure, or the higher the pressure, sorry. So we need to control the pressure as well. So there are a lot to take into consideration. We need to pressurize the inside and the outside of the aircraft so that we will not be crushed when we fly at certain altitudes. Now those are the graphs, and at 18,000 feet, at 18,000 feet, pilots needs to change their altimeter at 29.02 grams of mercury or pressure. Even at the ground, some pilots said this already, because beyond this point, mercury will change with the pressure and the temperature. Suddenly, the moment you go higher, and this means pressure is building up, as it was shown on the figure that I have explained, or that I have showed on your screen. Now, riding an aircraft at certain altitude is another thing. We as humans are like aircrafts. We have capacity and we have limitations. Aircrafts are equipped with pressure and temperature regulating system. Well, this helps all human on board to feel the same on the ground. While you're at the house, at your house, you'll feel the same, even at 45,000 feet. Although there are some very minimal changes, like the pressure. You'll feel your ears. You'll feel some pressure in your ears, and then the highest, and Of course, it will not be completely the same, but airliners, engineers do their best to make you feel the same or not make you feel the altitude sickness. Well, of course, we are humans. We are humans, and the question is, what are the effects on us riding high altitudes or being on a high altitude places? Well, the highest recorded place wherein a human have lived is at 90,520 feet, so that was pretty high. That is a world record. They have lived for about 2 years, wherein an aircraft can fly up to 40,000 feet. 40,000 feet. That is the normal cruise flight of an airliner. Rarely at 45,000 feet for non-military aircrafts. Space shuttle are not included, of course, because this is a different one. This is a different thing, or this is a different conversation. And flying at this altitude will have an effect on human body because we are not machines, specifically on our brain and on our respiratory system. As explained earlier, less oxygen are present when you go higher, and less oxygen can greatly affect our breathing. Common problems that we humans encounter at these altitudes are shortness of breath, confusion, lack of control of our motor skills. So, meaning to say, your walking ability, your moving abilities, is has been set with a certain threshold. So you cannot just force yourself to do something that you cannot. And motor skills, so pneumonia, dizziness, and nausea and fatigue. Even though aircrafts are equipped with pressure regulating system, human with weak respiratory system will still suffer from oxygen deprivation that usually leads to hyperventilation and other high altitude sickness like explained before. In order for us humans to feel the comfort of breathing oxygen inside an aircraft at a maximum altitude of 45,000 feet, airliners have come up with a brilliant air or pressure regulatory system. In a simple explanation, or the logic is to bring in fresh air via electronic compressors. Some uses bleed air to bring in air in the cabin and remove the used air that has been inhaled and exhaled by the passengers and the crew. To remove the air used from different passengers and crews through what we call the outflow valve. Outflow valve. I'll show you how it looks like. So, yep, this is how an outflow valve looks like. So it is a motorized small door at the empennage area that removes air. And speaking of outflow valve, just a quick trivia. During the early 1990s, smoking is allowed, or actually allowed, inside an aircraft. But once an aircraft reaches its periodical inspection, maintenance personnel have found trails of tobacco on aircraft's outflow valve, and it costs thousands of dollars to repair the damages from electronics and sheet metal. So this is where they decided to ban smoking from inside the aircraft. So going back, once the pressure is present inside the cabin, the cockpit, of course, there are also times wherein the pressure exceeds. And when this happens, a positive pressure relief valve, I'll show you how it looks like, so I'll flash it on screen. This is used to stabilize the pressure inside. This is also found in the empennage area, also known as the butterfly valves. We also have a negative pressure relief valve, also in the same place where the positive pressure relief valve is. Now this is used when the pressure is greater outside of the aircraft. Of course it happens. It usually happens on a sudden or continuous descent. So there are emergency scenarios wherein a pilot needs to control the plane to descend as quick as possible, like dodging a bad weather at a certain altitude. And however, even if the airliners and the engineers do their best to make us feel normal, apparently we may feel normal, but we are not. You may not recognize it soon, but you will be dehydrated due to low humidity. It is the other effects of us on riding an aircraft at a certain altitude or high altitude. We have low humidity, so we get dehydrated a lot. So human body needs plenty of water while in flight, to avoid altitude sickness. So it is a life hack for us to drink plenty of water if we are riding an aircraft or traveling through an aircraft. So that is the presentation about cabin or atmospheric components and the human respiratory system. I hope you all learned from me today, and I hope we could research on our own and explore more about aviation industry. And I hope you all have a great day, and goodbye.